If you're ever stopped for speeding, then you should know how algebra can help determine your fine.
Your license and registration, please.
And if you ever fly in a commercial airliner, then you might be interested to know how algebra can help air traffic controllers track the descent of your plane.
Visual approaching use, landed runway 16, a landing departure, radar contact.
In this module, you will learn how to express a relationship between two variables in symbolic form, how to use the symbolic form to find a value of the output variable. In many states, there is a direct relationship between a speeding fine and the speed of a vehicle over the posted limit.
How you doing this evening?
Algebra can help calculate this fine, but to do so, the relationship between the speed and the fine must be expressed symbolically.
Here's my driver's license.
Let's see how this is done. In this table, you can see the relationship between miles per hour over the speed limit and the related fine. The speed limit is 55 miles per hour. The base fine for speeding is $50 plus $2 for each 1 mile per hour over the limit. When we look at the number of twos that have been added to the base fine of $50, we see that it's the same as the number of miles per hour by which the driver has exceeded the speed limit. Therefore, a simpler way to determine the fine is to add 50 to the miles per hour over the speed limit times the $2 fine. Our new insight into the relationship between the two variables allows us to calculate fines directly without extending this table through dozens of additional entries. If, for example, a driver exceeds the speed limit by 20 miles per hour, we have 50 plus 20 times 2, or 50 plus 40, which equals 90. Notice that we must be careful to multiply the miles over the speed limit, 20, by 2 first. If we add first, we don't get the correct fine. To avoid confusion about which calculation to do first, mathematicians sometimes enclose the calculation in parentheses. To calculate another fine, just replace the 20 in this calculation with another amount over the speed limit. The miles over the speed limit and the fine are variables. Mathematicians use letters to represent variables in equations like this one. For example, if we use m to represent the miles per hour over the speed limit and f to represent the fine, we have this equation. This equation is powerful because it allows direct calculation of the fine without the use of an extensive table. So you can see that the symbolic description of a relationship is a very useful tool.
This is your captain speaking. We are currently cruising at an altitude of 35,000 feet, maintaining a speed of approximately 600 miles per hour. Our weather is clear and calm, so our landing in Denver should be pretty smooth. We'll be starting our descent in about 20 minutes.
Flight level 370 have been reported smooth.
How can algebra help track the descent of an airliner? Suppose a commercial jetliner is flying at an altitude of 35,000 feet, and the pilot begins a gradual descent at the rate of 1,500 feet per minute in preparation for landing. The relationship between the plane's altitude and the time that has elapsed since the beginning of the descent can be expressed in a table. The altitude drops at the rate of 1,500 feet for each minute of time that has elapsed since the descent began. When we look at the number of times 1,500 has been subtracted from the starting altitude of 35,000, we can see the pattern. We can now write a symbolic expression for the relationship by using a letter to represent the variable altitude and another to represent the variable time.
Delta 734 requesting flight level 370.
Delta 734, roger. Climb maintain flight level 370.
Delta 734.
With the help of this algebraic equation, pilots and air traffic controllers can confidently predict a plane's altitude at any time during its descent.
Runway 9 arrived, cleared to land.
In this module, you've learned how to express a relationship between two variables in symbolic form, how to use the symbolic form to find the value of the output variable.